Today our topic is voice recognition, and I think it might be very familiar with you guys. First, we are going to an introduction of this topic, and then we'll talk about the core technology of voice recognition, and I'll discuss some applications of this technology. And finally, we'll give you some prospects which we might think will be the directions of its future development. First, we should clarify some concepts used in the technology versus speak independent and speak dependent, which is used to differentiate whether the system used training to analyze and recognize the person's specific voice. And then some other classification includes using the number of vocabularies it used and whether it's continuous and discrete. The core technology involved in this process includes these kind of steps. First is to convert the analog signal to the digital signal, which is talked about in the lectures. And the second step is divide the signal into small segments and match these segments to the known phonemes in the appropriate language. This process is rather simple, as you can see in the picture. These are divided into small segments. And the third step is the most difficult step. It examines those phonemes in the context of the other phonemes around them, and it runs the contextual phoneme plot through a complex statistical model and compares them to a large library of known words, phrases, and sentences. Since it's the most difficult part, we'll cover it in the next page. And the final step is the program will determine whether the user was probably saying and either outputs it as text or issue a computer command. The first step, in early times, it used grammatical and syntactical rules. But it may not be able to handle those problems like person's dialect and some speech habits. And today we are using a more complicated and powerful system, which is the statistical modeling system. And we use some probability and mathematical functions to determine the most likely outcome. And there are the two dominant models in this approach is hidden Markov model and neural networks. They both take the information known to the system to figure it out and the information hidden from it. Since the HMM model is the most commonly used, so we will talk in details. It will use a statistical distribution to identify the probable outcome of a person's speech. Like if you want to recognize a speech, and they might be confused with recognize speech. So this model uses those mathematical functions to identify the probabilities of those possible outcomes. And it became more complicated when it concerns the sentences and paragraphs. So it requires training from both the developers and end users. Another commonly used model is neural network, and here we compare them in terms of their effectiveness and their scale. We think the optimal approach is to use neural networks as a pre-processing for the HMM-based recognition.
Alright, so now I'm going to talk about applications of voice recognition. And first, we see it coming in this logistic management, which there is a very famous example, which is also the first example in this industry, which is the roll collect and roll pump. And the basic process is like this. First, the computer will give me an instruction through a headphone. For example, suppose I have a headphone now, and it will say something like, go to desk 32, and then I will go to desk 32 to find some specific subject. And when I find the subject, I will read out, for example, I want to pick up this phone, and there is a check digit on it, and I will read it like 5563, something like that. Read it to my microphone, and then the system will check that, yes, you are picking the right subject, and then give me further instructions regarding the quantity and special orders, like pick up 5 of them and go to some place. And when I finish this, I will say something like test number blah 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 completed, and then the system will know that, yes, you completed and give you further test. And we can see that in this case, the voice recognition actually serves as something to help you free your hand, because when you're doing this kind of subject picking task, you need both your hands to be available. So this is how speech recognition helps you improve your productivity. And for the second kind of applications, it serves as an assistant for your personal management, in which the most famous application would be Siri. And here, let's put up a video about Siri launch.
I'm really excited. You can get to Siri at any time by holding down the home button for a couple seconds, and then Siri's listening to you. So let's go ahead and ask Siri about the weather. What is the weather like today?
Here's the forecast for today.
It is that easy. Not only did it understand the words I said, it understands the meaning, and it goes and gives me this weather forecast. But the exact words I say aren't important. It's the meaning behind the words. So I pass this in a completely different way. Something like, what is the hourly forecast?
Here's the weather for today.
Again, different words, Siri figures out the meaning. In fact, you can even ask more conceptual questions. Things like, do I need a raincoat today?
It sure looks like rain today.
So basically here we can see that one of the highlights of Siri is that you can speak to your phone very naturally, like you're having a conversation with a real human being. And you don't need to speak like, please send a text to my mother. You can just say, text my mom, or you can just do something like in a normal conversation, and Siri will understand it. And let's see how does it actually does it. We can see that implicitly there are 2 steps. One is Siri have to hear you. This part, it applies conversational service, which is something like you encode your analog signal into something digital. And this is where your conversation becomes something digital. And then the second step is Siri does something like it needs to understand you, which is here the personal context awareness. It will convert your digital signal into something it can process, a kind of instruction. And this is mostly about the personal speech recognition in personal management. And we can see that it mainly enables people to multitask, which will improve productivity. And from these core technology and applications, we want to say something about its prospects, which we see 2 ways of going. One is the speed. how we can make it faster. The first is to evolve your local processor and make it search faster. Or you can make your cloud service more sophisticated, so you can go online and search more vocabulary, so that it can make you so you can process faster. And the second way of improvement, we can see that is the preciseness. By improving the noise canceling technology, it will make your speech, you can comprehend your speech more precisely. So by these kind of improvements, we can see that voice recognitions may go into more fields. Something like the automobile, which actually now is already applying, like we know that Bentley does that, but we think it may go further. And maybe for TV operations, like you can say something to a TV and then you can do some instructions for you. And this will come back with some more feedback and more emphasize this part. This kind of learning process actually does not only exist in voice recognition, but also in many other interfaces. The computer go through a learning process by receiving more user experiences. This comes by two parts. First is about the quality, because when a sophisticated user speaks more with its Siri, for example, Siri can remember it. So your Siri may understand you better because you have repetitive patterns. So this can improve the preciseness of speech recognition. And the other part is quantity. Because more people use it, it will receive more vocabulary, and this improves in speed because there are more vocabulary to search. And we hope that maybe one day Siri can do your wish is command. So this is basically our presentation.